Good morning, good night, everyone, and welcome to the first public talk of AstroCamp 2023. Humanity's interest in the heavens has been universal and enduring. People are driven to explore the unknown and discover new worlds, and push the boundaries of our scientific and technical limits, and then push even further. But still, there's still some people that wonders why so many intelligent people spend their lives studying it, and why so many public money and private money is spent on it when you have so much problems here on Earth. But we can give three main reasons for that. First one is kind of obvious. Space exploration has brought us a lot of technologies we wouldn't have if it wasn't for it. For example, the computer that I'm using, the athletic shoes you use to run, the scratch-free lenses, you have heart implantable monitors, solar panels, water purification system, CAT scans, and I'm not even saying about things related to space, but our everyday life. And this one you may understand very well. Space exploration, humanity has always been driven to ask fundamental questions, and was always curious about the heavens. And every day, science is bringing fresh data that help us to answer questions that have been asked for millennia. For example, what is the nature of humankind bound to Earth? Is there life elsewhere in the universe? Are we on a planet unique? And I'm sure all of you must have a lot of other questions too. Also, space exploration helps us to address global challenges. By helping foster international relationships, we can be prepared for events like asteroid strike or space removal debris, and also help to foster relationships between the nations that can help to sign agreements to solve problems here on Earth. But okay, we know why people want to go out in space, but what exactly is the effect of space in the human body? And are these effects the same? Are there risks for the people that are going to spend 6 months on the space station, the same for those who may be away on a Mars mission for 3 years? And the simple answer is no. First of all, we have space radiation. Here on Earth, we are protected by the magnetic field and space atmosphere. But on Earth, the astronauts will not have that. And the radiation levels can be even 10 times higher than those we have on Earth. And this can cause mainly impacts on long-term health, like they can have more chances of developing cancer, heart diseases, and cataracts. One of the things they can do is watch for the movements of the sun and predict solar exposures, and that has the sun's most powerful radiation, SEPs. And they can know to prevent. So in the case of this kind of event happen, they can warn the crew so they can shelter. Because the most important thing is to put mass between the bodies so most of the radiation doesn't get to them. And this one is kind of obvious, but when I was packing for this trip, I was kind of anxious because I couldn't forget anything. I was going away for 3 weeks, and if I forgot it, that was it. And I kept imagining, if you're going to space, you cannot forget anything. If anything happens, it needs to be in there. So any emergency, even if it's medical, they have to get ready for that. And NASA does that by trying to figure out whatever has happened in the past and what may happen in the future. So crewmates receive technical and medical information to know what to do in a crisis. And they usually perform a regular scan on the organs to monitor organs' health. And if something happens, they can take analysis to do diagnosis and the right treatment. And also with artificial intelligence, they're incorporating more to help make the right diagnosis and be a tool more effective for the crew. We also have gravity fields. On a Mars mission, for example, they're going to enter 3 different fields. First of all, between the track and the planets, they'll be weightless. Then on a Mars mission, working and living, they'll be approximately 1/3. And then returning upon Earth, they'll have to readapt to Earth's gravity field. But transition to one field to another can be more trickier than it sounds, because it's going to affect their balance, their coordination, the head-eye movement and hand-eye movement. They're also going to have the fluids go to upstairs, and it's going to put pressure in the eyes, and they can have eye problems. Also, they're going to lose more calcium to their urine, so they have increased chances of developing kidney stones. They're going to lose mineral density in the bones, and comparably, like if you spend 1 month in space, you're going to lose the same as 1 year on Earth. And what they can do about it, they have different solutions, but some have not been. In space, you're going to be weightless, so you're not going to use your strength of your muscles to move around. So it's going to be really, if you don't exercise enough, you're going to lose all this muscle. So what you have to do is at least 2 hours per day exercise, and they can use cups on the thighs so the blood doesn't go up and doesn't affect their eyes and vision. And also they have scans that can monitor how much minerals you're losing. And this is one of the symptoms that Captain Scott Kelly, we are going to mention him in other slides, feel when he returned to Earth after spending 1 year in space because of transitioning gravities. Also, we have hostile environments. The environment of the spacecraft plays a big role in everyday life. Microbes change faster in space, and because astronauts will be in a closed environment, diseases can pass easier. So they always monitor the air, but besides that, they recommend the astronauts to get flu shots and to be in quarantine before the missions. And this is a really important study to understand how space affects human body. These are two twins, they're twins, and this is Mark and Scott, they're 2 astronauts. And Mark stayed on Earth while Scott was in space. And because of that, they could watch all the changes that happened during that time period in human body. It was mainly mutation in the DNA, but also Scott's heart got bigger after 1 year in space. He got a few inches taller, he was leaner, and he lost muscles even though he exercised a lot. His telomeres it showed like he was kind of getting younger in space, but you already know that. But these changes, they don't last a lot. They set back to normal after returning. And these are some findings they discovered, but they're more specific related to DNA. And after that, Scott wrote a book of his experience in space. And mainly, the title is Endurance. And we can talk endurance in both physically and mentally. And that brings us to mental health in space. This conversation about mental health in space started with Soviet pilot Valentin Lebedev, because he was in his 5-month mission. It was supposed to be a 7-month, but he started to have some symptoms that his crewmate didn't know how to deal with. He lost all his motivation to wake up. He didn't want to look outside. He didn't have any patience to deal with his crewmates or mission control back on Earth. And this was a wake-up call to all the scientific community of the importance that the mental aspect will have in the astronauts. And the first one, it is the amount of sleep. There are various factors that affect this. First of all, the spacecraft, they don't have any natural light. It's just blue light. And in blue light, it actually tells your body to stay alert. In that way, it doesn't produce melatonin, the hormone that puts you into sleep. And it's the same light we have in our devices. So that's why they say to never use a screen before going to sleep. But besides that, they have the noises of the other crewmates. They have to be in tiny cabins and have to stretch themselves to not flotate around space. And it can be really noisy, like the same amount of noise you have in the traffic on a daily basis. But this is more important so to astronauts, because if they don't get the optimal amount of sleep, they're going to lose their cognitive ability and also their ability to deal in any situation, any emergency situation that may occur on spacecraft. But medicine isn't always a good option, because the medicine will stop them to have a quick reaction any problem occur. But what we can do about it? Well, besides having a strict scheduled sleep, there's been developing devices like smart sleep. There's going to be wearables that they're going to wear during night. There's going to emit slow wave, inaudible waves to help them get in the optimum sleep. Also, space isn't just a physiological pressure environment. It's also psychological. They're in tiny, isolated spaces away from their loved ones, and they're always doing hard tasks while being examined by experts on Earth. And sometimes this pressure can gas them. There's even an example of a Chinese astronaut in the 80s that refused to get back on Earth after his experiment got wrong. But there is good news, because it is reported that most of the medical issues are not related to behavior problems, but more with lack of gravity. But even so, behavioral health, it is different from mental. It's not the same thing. It's mostly how your actions affect your well-being, like the things the astronaut, how they deal with the pressure, coping strategies, if they're social enough, what are their habits, lifestyle, if they cultural things. And even so, the behavioral health problems that the astronauts have are mainly concerned with earthbound problems. And what is this? This is the problems we have here on Earth when we are connecting with other humans, the problems that typically appear, like crashing personalities, if you don't know how to resolve a conflict, if you have demanding and violent personality. And that's why it's so important for NASA and any other agency to be really strict about the psychological tests and the personalities of his astronauts. So they pass through a lot of interviews, they pass tests, they cannot have any mental health problems. They have to, even if they have marital problems, they cannot go. And even after that, they are like trained in more strategies of conflict resolving, leadership, and among other things. And there is an interesting fact, like besides space being a total unsafe environment of a physical point of view, for mental health, it can be actually good. Because humans, it is a process called salutogenesis. It appears that when people are put in a really harsh and stressful environment, they can react in a way they will feel positive emotions. And this happens also with people that go in polar stations and submarines. And one funny aspect is that this happened mainly because of the understandable, they have the notion that this is a dangerous thing. They accept that, but they outweigh the risks. So they know that this is more important, like what they're going to, the reward is more important than the risk they're taking. And this is the main part of it. But also, even the astronauts say that the experience overall is a mental high one. And that can prevent astronauts from seeking help when they need it, because the pressure for success is so high that they are afraid if they ask for help, they're going to appear weak. But NASA, for example, is doing its best to predict human behavior, and this is one of the examples. This is a simulator that's been operating since 2014, and it replicates the confinement insulation that humans go through in space. It doesn't have microgravity, but they have strict sleep schedules, they have dried frozen food, they have to always report to mission control and have the delay and answer. And this is a good way to have more data about how humans act in such environments. But the message is that with 6 properly selected and well-trained crew members, humans can really thrive in space, because what we really need, and what all of us need, is these things. We need adequate sleep. We need healthy and good tasting food. We need exercise. We need meaningful work, leisure time, of social connection and recreation, and adequate space and supportive ground team. And I hope you have liked it. Thank you for your attention. That's it.